Alright, today we're going to be looking at the potentiometer. Okay? The potentiometer looks like this. And it has 3 pins at the bottom. I'm not liking this resistor or potentiometer too much because the offset pin here makes it really difficult to put it in a breadboard, but it will work for what we are going to be doing. So just make sure that it doesn't get squished if you're using this. So a potentiometer looks like this on a schematic. We have a plus on one side, a minus on the other, so a plus on this side, minus on the other. Or it could be vice versa. This could be minus or plus. This could be minus or plus. They always have to be the opposite of each other. And then the middle pin is the output. So that's the one that gets hooked up to the component. Now, what's kind of cool about these are they have a range, just like anything else. And sometimes they go from 0 to 10K. That's what this is. 0 to 1K. And there's lots of these, lots of them. Now, I would say that the higher this number, the biggest range here, the more it is kind of fussy. And I'll show you what that looks like when we read it with a multimeter, especially the cheaper ones. So right now, this is what it looks like in schematic. This would represent the middle leg on it. And now I'm going to show you how to read one with a multimeter, and then we'll look at one in circuit. Alright, so for this experiment, we're going to need potentiometer. Oh. Oops. Alright, so for this experiment, we're going to need our multimeter hooked up to the little hooks again. Okay. And it's going to be hooked up via ohm. So we're going to put it on the ohm setting. And then we are going to make sure this is ohm. See? Ohm. Alright, so it doesn't matter which one you hook up, but there is a way to do this. So let's say it was in circuit, right? So there's these little lines on the side. So let's say it was sitting in circuit here and the positive was going into here, the first line, and you wanted the measurement for the positive anyway. So you would hook it to the top one and the middle one. Okay, so when you rotate this, let's rotate it all the way one way. Okay? Usually if you rotate it counterclockwise, it'll reach its furthest state. So if I rotate it this way, it'll reach 10K. And the other way, if you'll see that it goes to near 0. Okay, now there is always a gap in potentiometers that are kind of cheap. So I'm going to rotate this and you'll see it. Do you see it? So it went from 0, then I slowly rotated it, and it's going up in ohms. So, oh, right there. See how it jumped? 300. It went from 300 to 0.4 kilo K. So there's always, and there's another gap right there. You can always tell the gap because it has like, it almost like zeroes out right there in that second. Right there. So that's only because it's cheap. To be honest with you, it's got some flaws in there. But other than that, they work and nobody's really going to see that one little gap. Unless you're reading a code from it using a microcontroller, then it becomes somewhat annoying. Alright. And of course, if you wanted to hook it so it is the middle and the last pin, it works just the same way. In this case, we have to rotate it clockwise to get it to go to 10K, and then it's counterclockwise to get it to 0. Confused yet? Yeah, you'll get there. So that's if you hook it up this way. So clockwise for the bottom pin, counterclockwise for the top pin to get to the 10K. Alright, so now that we have a potentiometer, we must learn how to use it. I needed to introduce it because there is an experiment later with a potentiometer.